Okay, now let's look at this problem, longest increasing path in a matrix. So what we are asked in this question is, we have to find the longest path which is strictly increasing in nature, which means let's say we stand at 1, we will look at all the neighbors and choose which is strictly increasing. So for 1, it is 6, which is strictly increasing, 2, it is strictly increasing. So these two are possible paths here which we can take. Now again we will look at from 6, which all are longest possible from there. Is 8 strictly increasing? Yes, it is. So we can add this also. 9 is also increasing. Yes. 6 it is not because it is equal. Um, that's all for this question, this path. And for 2, we can see that 6 is strictly increasing and then 9 is also strictly increasing. So we have found that this path is the longest path for which will start from 1. This will also be the longest path in this matrix once we test all the cases. So how can we approach this problem? One approach which comes to mind by directly looking at this problem is to visit every cell in the matrix and from that particular cell find which is the longest path starting from that cell. So let's say we uh, start from this 6 and then look at all the 4 directions. This direction, this direction, this and this. And we ask each cell to give us what is the longest path which starts from your end. So we will ask what is the longest which starts from 8, 9, 6 and 1. And then we will take maximum of this to find what is maximum of these all plus 1, max of all the directions. This will give me the longest path for 6. So what we are trying to do is to traverse all the cells and recursively call all the neighboring cells and asking them what is the longest path you have. I'll add 1 to that. So that is all about the recursive approach. So what will be the order of time complexity? It will be order m cross n into, since you have 4 choices, into k which is the average length of the path. But can we reduce this? One way to reduce is, once you look at this, we can see that for every cell, um, we are repeatedly asking what is the path for that a cell which we have calculated the answer before itself. 6 is asking 9, but what is the longest path? We have, and then again it will recursively call for ninth neighbor. But since we have calculated ninth answer previously, we can store it somewhere in a cache. So we will make a DP and memorize it to save us some time complexity. This will reduce this time complexity and then we will have it in order m cross n. Now this in itself is sufficient to solve this problem. This will pass all the test cases. But let's look at some other approach uh, through which we can solve this problem. Because we shall look at all the approaches because so that we can get the maximum out of some question. This is a hard problem, but once you look at this approach, it will look medium at best. So what another observation we can see is that these paths form a DAG, which is directed acyclic graph. You see that these are all directed. Let's look at this one. This is directed, and also this is acyclic because it will never form a cycle. And these all cells are uh, nodes of a graph. So what we can do is use topological sort to solve this problem. We will look by using Kahn's algorithm. Uh, we will directly look at the code for this approach. DFS plus memoization approach. Let's first take the variable m and n for the dimensions. Now let's traverse through all the cells of the matrix. And what we need to do is for every cell, we will calculate uh, the longest path using DFS, and we will store and we will find the maximum of all these paths. So we will have a variable named answer. Now these answers will store the maximum of all the paths. I, J, J are the source and matrix is the matrix which we need to pass. And then will return the answer. So now let's create this function named as DFS, which will give us the length of the longest path starting from I, j. So let's name this source row, source column, and vector, vector, matrix. Now let's look at what we have to do in DFS. As I mentioned that we have to check for all the directions. So first let's declare the directions also. Now this direction will be 2D vector. Let's name it DIRS. And also let's now 1 comma 0 will be for going down, minus 1 comma 0 will be for going up, 0 comma 1 will be for right, and 0 comma minus 1 will be for left. Now then again, what was the approach? To check all the 4 directions. So auto DIS, we can add here for faster execution. Let's create new variable named as I. Let's name it I only. I will be SR plus D0, and int J will be SC plus D0, D1. These are the new index these are the neighboring indexes, and we will check if this index are possible or not. So if I wait, let's check if it is not possible. If I is less than 0 or j is less than 0, or I is greater than equal to matrix size, or j is greater than equal to matrix 0 dot size, then what we can do in this cases, we can continue this loop and not execute further. Else we can check if matrix for this new index means the value of this new index is greater than matrix, means the original cell. So means the cell at I comma j is greater than cell at sr comma sc. If this is true, then what we can do? We can uh, recursively call the neighboring cell and ask what is the longest path from that cell. And for all this direction, we can take the maximum to get the answer. So we have to store this in a variable in, let's say, answer. Answer will be the max of answer, comma 1 plus DFS uh, I comma j comma matrix, and then finally we can return this answer. Okay, why 1 plus? Because we will add 1 plus what is the length of the path starting from 2. So let's check if it is correct. Uh, let's try to run this. Some compilation error, spelling error. Okay, yes, this answer should be 1 because each cell will have 1. Because if you see here 1, 2, 6, 9, its answer paths are actually 1, 2, 3, 3, but we have to calculate in this way that we should include the beginning also. So 1, 2, 6, 9, so 4. So it should start from 1. Okay, it has passed, but it will not be accepted because it will give time limit exceeded. Now next step would be to memorize this. So let's create a 2D vector. Let's name it DP, which will help in caching this, which will help in making the cache, which will store all the necessary previous results. This will be of dimension m comma n, and will have value in -1 for all the cells. Now we have to pass this in all the calls also, and let's give it here also. And DP. Now for every I comma j, we will actually sr comma sc, we will store the answer, and if at any sr comma sc we find that if this cell is existed, then we can then we can find directly return the answer. Okay, let's check. Here, past here, past here. Okay, it is passed. Let's try to run on all cases. It got accepted. Now we will look at the second approach. Okay, the second approach is the DAG approach, which is like topological sort. So what we need to do is uh, first we have to make a out degree 2D vector which will store all the cells out degree value. So what is that is actually is usually in Khan's algorithm, what we do is to calculate the in degree of all the nodes. But in this case, just for a change, we will calculate out degrees. What are out degrees is number of paths which are moving out of this cell. So let's take the example of this one. Here the out degree is just 1. For here 9, out degree is 0. So similarly, as we looked in Khan's algorithm, we look at all the the nodes which have in degree 0, we start from there. Then we do a BFS and traverse all the possible paths which can be taken. So a DFS of this, a topological sort of this will give us the longest increasing path. So let's start by creating a 2D vector. Out degree of same dimensions. And let's initialize it with 0. Now what we can do is traverse through all the cells. Let's also declare these variables. Now for every cell, what we need to do, again we have to declare this uh, direction vector, because we need to travel to all the 4 directions here also. 1 comma 0 for down, minus 1 comma 0 for up, 0 comma 1 for right, and 0 comma minus 1 for left. Now what we need to do is travel through all the 4 directions and then calculate the out degree for it. So for auto and d colon iris, we will make new variables x, which is the index for new, which will be I plus d comma 0, and y will be j plus b1. Now what we need to check if this index is possible or not. So how we will check that? Again same, if I is greater than equal to 0 and then j is greater than equal to 0 and then I less than we have this same value, right? So we need not to write matrix dot size again, and then j is less than n. Also we have to check if this path is possible or not. So matrix I, no, x comma y is greater than matrix I comma j or not. If these all conditions are satisfied, then this will be added to the out degree of I comma j. Now after this for loop, we can also check if this out degree I comma j is 0. Then we can push it in a queue so that we can do the topological sort. So let's push this in a queue. Let's also define this queue. this will be of type pair because we are inserting pairs. Okay, now what we have to do next? At this point, we have calculated all those out degrees for each cell, and we have pushed all those out degrees which have value 0. Now we can move to the sorting part. So let's calculate. Let's declare a variable answer which will store the r value. Next, we will do the usual uh, sort q dot size. Now, if we will check if this queue is not empty, then we can proceed. Next, we will increase this answer by 1 because this is the first node which we have visited. Now this at this point this should be 9, so 9 has out degree 0 here. So let's say we are starting from this. Now we are since we are standing here, we have increased the value of answer by 1. Now what we need to do, we will create a variable size, and for each now for all the paths which are emerging from 9 which are possible. In this case, is it 6 only? Let's say if this was also possible, these all steps would be processed in this for loop. So one level in each loop. So let's go from k equal to 0 to k less than size k plus plus. Now in each loop, what we will do, we will store the value. What value? Q's front value. And then we can pop this value. Now we have the top value of which is 9. Now what we need to do is we need to again check all the neighbors, find all the new index, and reduce their out degree by 1. Why? Because since we have removed 9 from this path, out degree of the resulting would be reduced by 1. And then again we will check the out if someone's out degree is 0, we will push it in a queue and then repeat the same process again. So this repetition is done by the while loop. So let's repeat the same for auto dirs. We will create a new index int x equal to I plus d0, int y equal to j plus d0 d1. Now what we need to do is check if these index are possible or not. So it's the same condition, but here's a catch. So since we are standing at 9, this new index should be less than the original I comma j. Then it is a possible path. So now let's decrease the index, decrease the out degree by 1, and now we can check if this out degree is 0, then we can uh, confidently push this new index in our queue and then return the answer. Let's check if it will run or not. So after for each level we are increasing answer by 1, and when this queue will be empty, it will come out of the loop. Okay, this answer statement should be out of the loop. Let's try and run it. Okay, one bracket is missing here. Okay, this should be x and y. Why have I done this? And here also it should be x and y. Okay, one blunder I made. Why did I don't know, but this should be q dot size. Okay, it got accepted. Um, let's test on all cases. It got accepted. Thanks for watching.